All right, so today we're looking at mathematics. More specifically, we're looking at the problem solving steps. All right, that's the steps that are involved in solving a problem. All right.
Yes, please.
Gavin, what's the first thing that you normally do when you're trying to solve a problem?
Miss, read the answer, miss, and try to work it out, miss.
You read the problem or the question and try to work it out.
Yes, miss.
Okay. Why are we reading it? Why are we reading the problem?
Just to get the understand it, miss.
Very good, Gavin. So that's the first step in the problem solving process. A lot of students do not know that, but the first step in the problem solving process is to understand the problem. And Sherry, why do you think it's important for us to understand the problem?
Because if you don't understand it, you'll get frustrated and want to quit.
Yes, so we might be frustrated and want to give up if we don't understand what we need to do, right? Sometimes we might push through, but that's rarely. Most of the times we might just feel frustrated, and even if we don't give up per se, we might just hurry up and get it over with, right?
Yes.
Very good that we understand the problem, so we feel confident and take our time to solve the problem, all right? So after we understand the problem, what is the next thing that we normally do? Even without knowing the steps, there are some things that we normally do. Some of us are aware of these steps. Others are just catching on to it. But what is the second thing we ought to do? So you can tell me what you normally do, and then if that differs from what you ought to do, then you can tell me what you ought to do. What is it that you normally do when you're trying to solve the problems today? When you see it, hopefully you read through like Gavin and understand the problem. But after you have read through, because someone has to read, what is the next thing that you do? Do you just normally solve the problem?
Miss.
Hold on, so then go ahead, Gavin, and then you can speak afterwards. Go ahead, so then.
Oh, wait, miss, repeat the question again, miss. Sorry.
What is the second thing that you normally do when you're trying to solve a problem? After you read it, what you do? What do you do?
Miss, you have to see if you understand it, and once you understand it, you have to take notes of the important keys, miss, and then use it to help you in what are you going to do to solve the problem. And once you solve the problem, you have to check over the
all right. We're not at solving the problem as yet.
Okay.
So you said that we're identifying keywords and clues. Let me take that away from what was said.
Miss.
You're going to say something, Gavin, all right, go ahead.
Miss, you read the problem, you read out, miss, you read what you have to do, miss. Like if you want to subtract and divide and multiply, miss.
Okay. But how do we know what operation to subtract, add, multiply, and divide? How we know what operation to use? So like,
miss,
go ahead.
Miss, miss, you have to read it. There's something, miss, to know which one I have to do, miss.
You have to read the problem. And that's something that you're mentioning is the keywords. We have to identify the keywords, right?
Yes.
To find out what keywords are in the problem that tells us what operation we must use, right?
Yes, miss.
So when we identify keywords, we can also do other things as well. We can draw diagrams. We can make tables, as well as we can do both. We can identify keywords and then we can draw diagrams afterwards to help us to solve a problem or assist with the keyword in solving the problem, right? All of those things that I just mentioned are parts of a plan. Okay? So we can, so that's the second step in the problem solving process, right? To make a plan for solving the problem. Okay? So we can make a plan, and that is basically finding a problem solving strategy. We can make a plan by using keywords and clues. We can act it out or use tokens. So when we were in kindergarten, we used bottle corks, or we use stones, or whatever we could find our hand, or we could use what they call it, the fudge sticks, right? All of those are tokens that we can use to act out the problem, yes? Especially like 10 and 1.
Miss, you can also draw strokes to miss.
We can also draw strokes, so very good. And that's the part where we said draw a picture. So we can draw pictures, we can draw circles. Sorry, we can draw circles. We can draw strokes. We can, if it says pencils, we can draw actual pencils as well. Suppose it says Santa has 10 oranges, we could actually draw some oranges as well, all right? Or draw a circle to represent these oranges, whichever is easier and more quicker for us to do, all right?
Yes, miss.
We can also find a pattern. So a lot of the problems have patterns there. We can look for that pattern. We can also guess and check. When we talk about guessing and checking, we're not just making any old guesses. We have to make collective guesses and make sure that we check our guesses to make sure that the answer is correct, right? We can use tables and charts. We can use number lines. We can write a number sentence or equation, or we can work backwards. All of these will be, or simplify the problem. All of these will be looked at in subsequent classes. Sometimes when we see bigger numbers, we get frightened and don't want to work with them. But if we use simpler numbers, then we are able to understand it. So we can work it out easier, right? All of those are strategies, are ways to solve our problem. And we must try to implement it rather than just trying to work it out. Because when we go to work it out, we don't always get it right. The plan is what is going to make us succeed, right? Similarly to real life, this is where we make the connection with real life. Mathematics and real life is very much coexistence, or they are related to each other. But when we start doing the planning, that's how we realize that. In truth, we plan every day in our lives, right? If we're going to a keeping a party, going to a party, going abroad on a trip, and going locally on a trip, whatever we do, if we're going to school, we're going to a class party, we'll do some planning, right? A lot of things that we do encompass planning. And when we are good planners, we are good problem solvers. So when we make good plans, that's how we're able to problem solve well, right? So that is a vital part. Some of us did not know it. Some of us were doing it and did not realize it was a part of a plan. So we need to incorporate that knowingly that we're going to make a plan to solve our problem, all right? The third thing that we're going to be doing is to carry out the plan. So say for instance, we made the plan to draw a diagram. We will carry out that plan using the diagram to solve the problem, all right? If we made the plan to use the diagram and we don't use it, it is almost as bad as if we didn't make the plan at all. So it's very important that we carry out the plan to solve the problem so we get the right results that we desire, okay? Which is ultimately to get the question correct, right? Finally, when we carry out that plan to solve the problem, trust me, we are going to look at it in more detail that when we are finished with the plan, the problem is already solved. We don't need to try to do anything else outside of the plan. We don't need to work out anything. The only thing we might need to do is to have some statements along with it, but we don't need to work out anything, right? So when the problem is solved, we move on to the last step of the problem solving process, and it's to look back and reflect on the answer in terms of the initial question. What this means is that we're going to look back at the answer, but not only look back to it to say that it's correct, we are going to also look back at the question to make sure that we understood it in the first place, right? We're going to look at a problem, and then we're going to see how we can implement these steps and one of these problem solving strategies, okay? All right, so let's try to understand, see why it is important in depth to understand the problem. As good problem solvers, we will ask ourselves some questions. What is the problem about? What it is asking us to do? We will monitor our progress. This means that we will not fall off course, right? Sometimes we're working with some small numbers, and when we look at our answer, the answer has very large numbers. That means that we went off track and we didn't monitor our progress, hence we did not know that we went off course. All right. As good problem solvers, we also re-evaluate our choices. So if we made a choice to use a particular plan, when we use that plan, if it's not working, we will choose other plans because we will see that this choice that we made before was not the best option, all right? When we make a plan, as we said earlier, it helps us to gain insight into the mathematical relationship, that relationship that mathematics has with real life. When we make a plan, we're able to see that relationship, all right? Making a plan also helps us as students to learn more sophisticated ways of solving our problem. Sorry about that. And we look at the problem solving strategies already. When we're carrying out the plan, we will carefully monitor our solution procedure. Meaning, similarly to what we will do when we're understanding the problem, to monitor our progress, we will make sure that it is going in the correct order, okay? We're not leaving out anything. Sometimes when we're carrying out the plan, we realize that that plan will not work. Similar to reevaluating our choices, we might have to come up with a new plan. And that's how plan B comes about, right? We go to plan B when plan A does not work. When we're looking back at our answer, we're checking if the answer is reasonable. Does it make sense? And how do we know it's correct? Some of the times when we look back at our answer, we realize that we did the incorrect thing and we have to go back over it and make adjustments, right? To check some of the ways of how we can check if our answers are incorrect, we can, instead of multiplying, we can add, right? Because they're almost opposite, right? Instead of dividing, we can subtract and so on, all right? So let's do a revision of the steps in the problem solving process. We should understand the problem. By understanding the problem, you're gonna see how we restate the problem, which is leaving out some of the first word and then just have the problem as is, right? I'm gonna show you how we do that when we look at the problem. We'll also make a plan for solving the problem, This is what strategy we decide to use for solving the problem. All right. And the strategy is just finding a way. All right. Simply speaking. When we carry out the plan, we're trying to check if our plan works. Otherwise, we said we're going to make another plan. All right. You were saying something, Anna? Your hand is raised.
Miss, I was saying, what if you read and understand, but when you're, like, if you're doing a test, and then you seem to understand, and then once you give in the test paper, you feel like you weren't supposed to put that answer and simply just give up and say that you did not understand the question, and you get frustrated that you're going to fail. What will happen?
Okay. I think what happened there so it's not what will happen, because you just literally have to wait until your grades return to see if that suspicion that you had, if you did the wrong thing, you have to see if your grades come back to see the paper and see if you did the right thing, right? But I think what happened was that you didn't truly understand the problem, right? Because if you truly understood the problem, you would have known exactly what it is asking you to do. And if you had made a proper plan, then you would see. I'm telling you, when we start doing our planning, we'll see definitely how we get the answer. And there's not going to be any if or but to say that the answer could be wrong, because you're going to clearly see how the answer is correct. All right? So finally, we look back, and that's why the look back process is important too. Because if you look back at the problem, there is when you should realize whether you did the correct thing or not when you're handling the paper, all right? So we really have to spend time and look back at our problem and the answer to make sure that, one, we understand what it's asking us to do in the first place, and that we did the correct thing, all right? When we also look back, we try to see if there were other ways of solving the problem, all right? If we could use another solution, okay? All right, so let's try to look at the problem. I'm bringing it up to the screen. And this is a scenario in where we're gonna actually, I'd hope to draw a helpful diagram. Let's see. Time might not permit us to do that. Let's open up a document with where we can use keywords to solve our problem, all right? All right, so let's quickly look at the keyword list. These are some of the keywords for addition, add, all together, and both in all. Sum, total, increase. Does someone want to read, or does anyone want to read the subtraction keyword list?
Can I do this?
Where?
Subtraction. Difference, fewer, gave away, take away, how much more, how much longer, shorter or smaller, left, less, change, decrease.
All right, some of the multiplication keywords are each, same, twice, product, in all. Each must be in that sentence as well. Double. Some of the division keywords are share equally, each, quotient, and every. All right, so let's look at the problem. Let's go to this problem here. So for this problem, For problem number 1, we're going to be underlining the keyword or the clue word in the problem. We're going to write an equation. So those are 2 plans that we're going to use. We're going to identify the keyword as one plan, and then we're going to write an equation as another, and then we're going to solve the problem using that equation. All right?
Yeah.
All right, so let me get the problem a little closer to the screen. So we can look at those 2. So problem 1 says Mark had 17 gumballs. He gives 16 gumballs to Amber. How many gumballs does Mark have left? What is the keyword in this problem? Is anyone seeing it?
Miss,
Yes.
it is subtraction, miss.
Yes, we're supposed to be subtracting, but what word tells us we're going to be subtracting? And that's the keyword.
How much?
How many left?
How many left? So we have how many, but we can't leave off the left. So it's how many left, all right? How many and left, all right? So let's highlight those words. All right, so let's write the equation now. What equation can we write to solve this problem? What equation can we write to solve this problem? Anyone tell me? You can type it in the chat as well.
Subtraction.
No, tell me the equation that includes the subtraction. So we know left tells us we should subtract, so we can put the subtract here and we can put the equal sign, right? Because it's an equation, it needs an equal sign. All right? But what are the numbers that we're going to put between the subtraction and
17 and 6.
Where must the 17 go?
The 17 must go before the subtraction symbol. And the 6 must go after the subtraction symbol.
After the subtraction. What's that 6? All right. 6 from 17 equals, subtract 6 from 17
11.
11. Very good. So we've solved the problem. It looks like work, you know, but it's really an equation, all right? So we use an equation to work out the problem. So are we clear on how we got the answer for this question or this problem? So Mark has 11 gumballs left, right?
Yes.
All right, let's add this other one. Sarah and her 2 friends bake a pan of 12 brownies. All right, go ahead, Jamal.
Sarah and her 2 friends bake a pan of 12 brownies. If the girls share the brownies equally, how many will each girl have?
All right, so let's find the keyword. What's the keyword here? What's the keyword? Equally. There's actually another one. Both of them go together.
Miss, can I say?
Yes, please do.
Share.
Share. So share equally tells us what operation we're going to be using.
Division.
Division. Does everyone understand that?
Yes, miss.
Yes. If we look back at the keyword list, you would see that. All right. All right. So let's go ahead with an equation now. What are we going to be writing? I can do the same thing like what I did before. I can write the division symbol or sign, and I can write the equal sign. What are the numbers that we're going to be using?
Well,
So we know that because she has 12 brownies, but how many persons are friends are she going to be divided?
So
Hiding it.
Sarah, 3. Sarah,
2. Explain to me how you got.
Sarah and her 2 friends, it will be 3.
Repeat.
3, miss.
Oh, we got 3.
Because Sarah would equal one person, and it says that she has 2 friends, which would be 3 people overall in total.
So Sarah,
Altogether.
including her friends, would be 3. And so we're gonna divide 12 by
4.
3. We divide 12 by 3, we'll get 4. So each of
4.
us will get 4 brownies. Are you seeing that?
Yes, miss.
We could finish off with a statement like this. Mark had
11.
11 gum balls left.
Miss, you mean has?
Repeat.
Do you mean has?
Or has. And we can say that each girl
Got or
got, see, we see the got. It can be in any tense. Get 4 brownies. So now, Anna, are you seeing that we can't make any mistake now when we make our plan?
Yes.
This is definitely sure we know the answer. There's no if we did the wrong thing, we can clearly see that the correct thing was done here by making the plan of writing an equation or a number sentence. All right. Are there any questions? Are there any questions?
no, miss.
What we did today was totally understood.
Yes, miss.
Okay, great.
Clear.
That's where we end for today. I will share the link for the class so you can revisit it on the YouTube page and look over what we did and reinforce what was learned today. All right. So we'll have another session similar to this one next week where we'll just focus on performance tasks. All right.
Yes, miss.
All right then. Have a good weekend. I'll see you all next week.
Okay.
Bye, miss.